Alright, I want to talk to you something about the relationship in a circuit between a voltage, some amount of resistance, and the amount of current flowing through the wire. Okay, so now what's happening is electrons are dancing through the wire trying to get to the positive end. They actually move very slowly, but as each one moves, they're pushing the one next to them. Okay, and so the rate at which they move is significant. And actually, when we talk about current, we're actually talking about it as if it's moving this way, even though there's electrons flowing in the opposite direction. Okay? And so the rate at which they flow depends on how much resistance is in the circuit. So like when you made a circuit with 2 light bulbs, you saw that they got dimmer. Well, the reason they got dimmer was because there was less current flowing through them. Okay? And if we had a third one, they'll get even dimmer, because that would mean that there's even less current flowing through them. Okay? Well, we can also do something that would brighten those bulbs. Okay, so let's make a circuit with a bulb. Okay. Now, this bulb is going to burn at a certain brightness, and will continue to do so. If I add a bulb to it in parallel, this one will also burn the same brightness. They should be about the same as it was before. What's happening here is, instead of limiting the current, we're actually allowing more current to flow. And so the same amount of current is going to flow through this one, and now it's going to flow through this one too. This bulb right here doesn't even really know whether that bulb is there or not. Okay, it could be there or not. This bulb can't tell the difference. Okay, and this is why your house is wired in parallel, because you could have a whole bunch of parallel circuits, each one acting independently of each other with no knowledge the other one is there. Okay, so the next thing I want to talk about though is the mathematical relationship between voltage, current, and resistance. Okay, if we have some voltage and some resistance and divide them, that will tell us how much current is flowing through the circuit. So if we increase the voltage and keep the resistance the same, that means more current will flow. If we add more bulbs in, increasing the resistance but keeping the voltage the same, that will cause less current to flow. And that's why as you added those bulbs, less current flowed because you had a larger resistance. Okay? This relationship is called Ohm's law. Okay? The person that came up with it is also the person who the unit for resistance, the ohm, is named after. Okay? But what it means is this. Let's say that I have a battery with 6 volts, okay, of potential, and let's say that there's a bulb here with a resistance of 1 ohm, okay, so, sorry, that's the wrong symbol, 1 ohm, okay, well, what that tells me, I can actually predict what the current would be. So, V over R is equal to I, okay, if I know the voltage, and I know the resistance, that will give me the current, okay? And volts divided by ohms are going to give us amps. So this is a current of 6 amps. Now 6 amps is actually a lot of current, okay? So let's go back to the scenario. It's far, far too much current for any application that you would use. That would be, if there was 6 amps of current going through your body, that would be enough to kill you, okay? So instead of using 6 amps of current, let's say that we want to take the same circuit, okay, and let's say that we want to limit the current to 200 milliamps so that it doesn't burn out. Let's say there's a bulb or something. Okay, well 200 milliamps, and this is kind of the common unit we use for current, would be 0.2 amps, okay? So if I have a voltage of 6 volts, okay, if I want to know how much resistance I need to limit the current to 0.2 amps, okay? Well, to solve this, what I'm going to do, I'm going to swap these guys, okay? So 6 volts over 0.2 amps would give me a resistance. 6 over 0.2 would be So this would give us 30 ohms of resistance. Okay, so we would need 30 ohms of resistance if we want to limit the current to 200 milliamps. Okay? Okay, so here's a circuit. I have a 5-volt power source. Okay, and I want to limit the voltage through the circuit to a current of 10 milliamps. Okay, 10 milliamps or 10 thousandths of an amp would be 0.01 amps of current. Okay, given that, I want you to use the relationship Ohm's law, V over R equals I, to determine how much current or how much resistance we need in order to limit that current. Okay, so you should pause the video and do that calculation. Alright, once you've done it, we can go ahead and say, alright, the voltage of 5 volts. We want to know what resistance. We have a current of 0.01 amps. We divide it over 5 volts over 0.01 amps. Will give us a resistance of 500 ohms. Okay? So 500 ohms of resistance there. Okay, I'll give you one more to do. Circuit with a 9-volt power supply that is connected to a resistor with 10,000 ohms of resistance, or 10 kilo ohms. Okay, what I want for you to do is to go ahead. Okay, so let's go ahead and calculate. So we use Ohm's law again. We want to find the current through the circuit. Okay, with the 10 kilo ohm resistor and the 9-volt power source. When voltage, remember, divided by resistance is equal to current. So go ahead and solve. Once you've done so we could substitute 9 volts for voltage, 10,000 ohms for resistance, and solve for I. Alright, and so we get, after dividing, 0.0009 amps, or 0.9 milliamps. So this is a very small amount of current, but which would be typical in some of the kinds of circuits we'll be building.